This is problem 46 from chapter 3 of our textbook, and I just thought I'd go over it again because it's a good example of Newton's third law. So what's going on here is that we have two blocks, A and B, that are actually touching, but I've separated them just so that we can see things clearer. And the idea here is that block A pushes against block B, so the force of A on B is 20 newtons. We know that the mass of A plus the mass of B is 12 kilograms. And the other thing we know is that if we were to turn the problem around, or turn the blocks around, put B first, followed by A, that in this case, the force of B on A is going to be 10 newtons. The problem, as is written, actually says that the force that A exerts on B is minus 10 newtons. So the idea here is that in this case, the block A is pushing back against block B with a force of 10 newtons. And because of Newton's third law, for every action there's an equal and opposite reaction, or the idea that forces come in pairs, we know that the force that B exerts on A and the force that A exerts on B are just equal and opposite. So let's see if we can use this information. What we know is that the acceleration of the system, we know that the force exerted by A is equal to the mass of A plus the mass of B times the acceleration of the system. We also know that we can look at either one of these and see something very interesting. Let's look at the lower one. We can say that the force of B on A is 10 newtons, and that's going to produce an acceleration on mass A that we can figure out in a second. And then looking at the top, the idea here being that 10 newtons is going to accelerate whatever mass A is with some acceleration. I can write a similar equation using the upper case and say that the force of A on B is 20 newtons, and that's going to accelerate mass B, or block B, with an unknown acceleration A. So if I look here, I have the applied force is equal to, and I'm just going to take that A and bring it inside, mass of A times acceleration plus mass of B times acceleration. And you see I have that over there, so that I know the total applied force is equal to 10 newtons plus 20 newtons. This coming from there, this coming from there. That gives me a force of 30 newtons accelerating 12 kilograms, which we know is the combined mass, multiplied by A. So the acceleration is 2.5 meters per second squared. So I have in essence solved both parts A and part B. And the important piece here is just that it's interesting, since mass B is heavier, is greater, clearly it's easier to accelerate the lighter block, which is why we had this situation where, coming back to here, notice that when light block accelerates heavy block, it took 20 newtons, but when heavy block accelerates light block, it's only 10 newtons. And we talk about these being like the contact force. And its official name would actually be the normal force.